All right, we're still in Unit 2. This is Chapter 10 on how to re-express data. So we're going over some strategies of looking at the data, looking at the scatter plots, looking at the residuals, seeing if the data does fit linear, and if not, let's make it fit linear and strategies for doing that. So if I'm moving too fast through some of these examples, please try your best to pause the video, write the problems down, and then come back to it. But it says here, at a meeting of the International Astronomical Union in Prague in 2006, Pluto was determined not to be a planet, but rather the largest member of the Kuiper belt of icy objects. All right, let's examine those facts. Here's a table of the 9 sun-orbiting objects formerly known as planets. So here they are, the planets, the numbers and the position. This is the distance from the sun, of million miles, and the length of year, Earth years. Before getting there, so it says plot the length of years against the distance from the sun and describe the shape of the plot. So you have your two lists. Okay. So plot the length, describe the shape. So we have the length of years in the y, the distance in the x, and it's looking positive. It looks like it could be linear. Looks like there could be an association, but it also looks like it could possibly curve because it says the association between distance from the sun, and planet years. It's strong and positive, but it looks like it's curved, kind of concave upward. And generally, planets farther from the sun have longer years than closer planets, obviously. So point is, and this is the length of the year, meaning like our year version of Earth years. That's why that's a 1, just in case you were curious there. Mars's Earth year in time is a little bit longer than it would be because it takes a longer trip around the sun, where all this is coming from. But anyway, point is, it looks like there could be a pretty strong positive association. It's a little curve. It says re-express one or both variables to straighten the plot. Use the re-expressed data to create a model describing it. Well, the rate of change in length of years per unit distance appears to be increasing, but not exponentially, right? Like it's increasing. It's not increasing like, like a huge curve. So it says re-expressing with a logarithm of each variable may straighten a plot such as this. So the point is, if you're noticing that the points tend to bend a little bit, all right, not just, they get higher as they always get higher as they get older, but if it looks like there could be a small bend exponentially, log is good to help out with that. And it says sometimes you want to log one, or you can log them both. So it says the scatter plot and the residual plot for the linear model, to save some time here. It would be the best if we were to log both, because if I take the time to log distance and log length, look how straight that puppy looks. Looks pretty straight, right? So what they're saying is, if you were to log each of the values in the table, log each of those and plot them now. Like if you went to your scatter plot and do it, you would get this, which means they would give you this data right here. And now I can notice very little pattern. That would be for my residuals, which means it's probably a pretty good use of this. So in order to figure out anything now, it says comment on how well your model fits now. To me, it's practically 100%, if not 100%, right? So the model explains 100% of the variability in the log of the lengths of the planetary year, at least according to the accuracy of that software that they used. And you would see that too with if you were to do it on your graphing calculator and log each variable and then go to line reg and then calculate it and then look at a plot of the residuals with it as well. But the residual plot is pretty scattered and the residuals are, they're pretty strong. So it's a pretty accurate model. So taking a look at this, it says look again at the patterns, re-express the distance to create a model for the distance from the sun based on the planet's position. So distance from the sun and planet position now, and based on the model, would you agree with the International Astronomical Union that Pluto is not a planet? So the point is, the association between them, you plot them both scatter plot wise. The association between planetary position and distance from the sun is strong or positive. Now, even if you didn't plot them, notice how as you go over one, they do appear to continue to go up. So they do appear to be positive. All right, now, granted, to me, how much is the jump each time? Like, it looks like it's doubling. a little less than doubling, pretty close to doubling. That is a little more than doubling, but then it's doubling again. Then it's roughly-ish doubling again. Like it looks like for the most part, it's not consistent, but it says a good re-expression of the data is a position to log the distance. The scatter plot with regression line, right, shown here is this. So the point is you would notice kind of like a pattern, and you could plot them all to see that on your own, but the residual plot may have some pattern, but after trying to several re-expressions, meaning maybe you try to log, maybe you try to log both, right, what you're going to realize is this is the best fit that you could get. You log the distance, but not the position. And you would realize that 98.2% of the variability in the log of the planet distance from the sun is expressed. But again, you would plug these all in. And after you plug them all in, what they're saying is you could try to log both of them, but it works out pretty well if you would just log the distance only. And to think about it here, that's only going over 1 each time, so I don't know if it would be worth your time to log those numbers and log them both to re-express it. But if you're noticing any kind of pattern with them, then you might have to take the time to do that. So here is the position and the distance, and if you notice, it kind of looks exponential, and what they're getting at is if it looks exponential, if you log these, it'll drop them down more and make it just the y, it'll drop it down and make more of a straight line out of it. So if I log just the distance, notice that it does become a bit straighter, which is what is happening there with the points. And then with the regression, I'm not really noticing a model with that regression either. So it says, based on the model, would you agree with the International Astronomical Union that Pluto is not a planet? So if we were going to do this, it says, at first glance, this model appears to provide little evidence to support what the astronomer is saying. Like, how am I supposed to know just from this that it's helping? But Pluto appears to fit the pattern. Although Pluto's distance from the sun is a bit less than expected, a model generated without Pluto does not have a dramatically improved residual plot. So it does not have a significant higher impact nor a different slope. The point they're getting at is if I remove Pluto from my data, is it altering what's happening drastically? And no, it's not. Pluto does not appear to be very influential in this at all. But don't forget that a logarithmic scale is being used for the vertical axis. The higher up the vertical axis you go, the greater the effect, or the smaller the change anyway. So yeah, I can remove that data point. I can remove Pluto, and it's still pretty close. It's unaffecting it. So you could argue that point. But if I take 9, because it's the 9th planet, plug it in here, and then because it's a 10, I put a 10 to the whatever on both sides, I get approximately 4,844. So according to the model, the 9th planet in the solar system is predicted to be about that many million miles away from the sun. And Pluto is actually 33,707 away. So Pluto doesn't fit the pattern for position and distance in the solar system. So what we're getting at is, if this is a pattern that I'm supposed to follow, right, as it goes around, and this is what we made, it says that Pluto's actually supposed to be this, but our prediction is saying that the next planet is here, meaning it's misplaced from where it should be according to how everything else is predicted. In fact, the model made with Pluto included isn't a good one, because Pluto influences those. The model without Pluto, all right, if I log it and get this, it's better, right? The actual thing is better. It works much better. It has a higher R squared and scattered residuals plots. This new model predicts that the 9th planet should be a whopping 5,699 million miles away from the sun. There is evidence that the IUA is correct. Evidence doesn't mean that they are. But what they're saying is if I took that away, I might even have a more accurate model in doing this. Pluto doesn't behave like any of the other planets do, is the point, if you were to use this model and its position and its distance away. The asteroid belt between Mars and Jupiter may be the remnants of a failed planet. So meaning it tried to be a planet, but maybe it blew up, or maybe it just never kind of mustered. But if so, then Jupiter is really in position 6. Saturn is in position 7, right? And so on, and repeat exercise 19 using this revised method, meaning what if it's in different positions? So the point is using the revised planetary numbering system and straightening the scatter plot using the same methods as it in 9, if we log the distance, all right, is a slightly better fit. So what they're saying is there's an asteroid belt between Mars and Jupiter, and that may be the remnants of a failed planet, meaning it tried but it blew up. So there might have been a planet between Mars and Jupiter. So if so, then Jupiter is now pushed back one, Saturn is pushed back, and so on. So what it's saying here is, using this revised method, knowing that there's a planet, we would have to figure out where that asteroid belt is to place it in there. But the point is, what they're suggesting is the new model is right here. If we just skipped that and pumped everything back, so we no longer have those positions, and it's like there's a gap position there, and it says 1.32, which is what it would be. So just remove Pluto from it, but then change Jupiter's number. So it's now Jupiter would be 6, and then Saturn 7, and then Neptune, I guess, or no, not Neptune, Uranus 8, and Neptune 9. Like, move them out of position and then redo everything is all that we're saying. Change that. And if you do, what they're saying is, if you log the distance, you would get an even straighter line, better in position, better fit, and the residual plot is more scattered than all of them, and R squared is slightly higher, with the improved model explaining 99.5% of the variability. So it actually would make more sense that there could have been something that happened there, is the point. Because here's the distance from the sun if we basically skipped that, right? I no longer have a 5. I moved all the data to 6 and move it over there. And then when I log just the distance, because it's still exponential, it's even straighter. It's even more accurate, is the point that they're getting at. If you look at all that, and the residuals are all over the place. So Pluto still doesn't fit. Even if I was to do that, the new model predicts that Pluto, as a 10th planet instead, should be about 4,169 million miles away, and that's about 462 million miles farther away. So it still doesn't even fit. A model made with the new numbering system, Pluto, still wouldn't even work, is the point, even if we altered that number system. All right, I'll stop there, and when we get back here, hopefully we can finish up some more of these practice problems.